All right. Hey everyone, welcome to my stream. It's been 2 days since I last streamed. Last stream was pretty cool. I ended up finally fixing that elusive bug that I was working on for the last few. It was this bug where running my Vectrex emulator and running the default Mindstorm game, it would eventually access some memory that was in cartridge space that didn't make any sense. And what I did last stream, if you didn't catch it, was I integrated, like I hacked in a CPU emulation that was written for another Vectrex emulator called Vectrex. And what I did is I ran it with my own emulator and was able to generate my trace from my debugger and compare it against the one that my own CPU implementation generates. And in diffing the two, I was able to hone in on one specific problem, which happened to be one of the ways I would compute an offset in the indexed addressing mode. I think that's right. So yeah, so basically doing that allowed me to fix that annoying bug. Sorry, I'm just gonna say that I'm live now on Twitter. Okay. Right. So yeah. So that was last episode, which was 2 nights ago. Now, since then I was hoping to do a little bit more preparation for the stream in terms of reading some docs on how to do rendering for the Vectrex, but I didn't really have time for that. One cool thing though that I did do, so I want to just kind of show that. I touched upon this last stream. I wanted to be able to assemble the BIOS. So the BIOS, you know, the source code for the BIOS is something that was disassembled by someone, Christopher Solomon, it seems, or somebody who did it first, and then after that it was corrected and compatibility added by Christopher Solomon. Anyway, did a great job of breaking up the BIOS and documenting how it works, putting comments everywhere, giving names to all different routines, which is super useful. And the thing is, though, I had all this, but what I didn't have, and you can kind of see it here, is this is just a source, right? What I don't have is a way to know exactly which address every instruction falls at. So when I'm debugging or tracing through the BIOS in my debugger, I kind of have to do this kind of manual looking up for a series of instructions and see if I can figure out what's going on and match it up with the BIOS. I have a few hints, like some labels, and here are really the labels that represent the address, let's say, of that instruction. Like this one here is at F09E, and this one's at F0A4. So those kind of anchors help me a little bit, and they're here and there, but they're not everywhere. And what's not useful though is let's say I know it's around here. Okay, maybe it's not a good example, but let's say I take a JSR somewhere. Yeah, say I know that I'm near this place, and then there's a jump to a subroutine, and then I have to step until it comes back so that I can reach this, and I have no idea what the address for this guy will be, or I mean I can compute it, but it's not easy to figure it out and to put breakpoints. So all that to say is I thought to myself, man, it would be cool if I could assemble the BIOS. The problem is that the BIOS, at least by default, was written for, when it was disassembled, it was for a different assembler, not the one that is now commonly available for the Vectrex, which is called the Kingswood assembler. So it's this one here, ASM09. No, sorry, AS09. The AS09 assembler for M6809. Frank A. Kingswood wrote it, so it seems to be commonly referred to as the Kingswood assembler. And this assembler, he kept it up to date and got it, made sure that it builds for Windows x64 without any issue. So that's what I'm using, but the thing is that the BIOS was written in a format that's not compatible with this assembler. And so what I said last stream was, hey, you know, I could do something about this. I can make kind of like, if I take this BIOS and start rewriting it, just modifying it just so that it could compile with this, it would be really cool. And as a hint to getting that done, see if I can find it. I showed it last stream. I think I have a note. Let me see here. In my agenda, yeah. That's it. This guy, Mike P., he took the time to take a disassembled version of of Mindstorm, which was, I think we can take a look at it here. How do we view this? Like this? Oh, okay, sorry. This just is README here. It's not the right thing. So I'm just going to show, what's this, HTML? Okay, that's not useful. Oh, okay, yeah, because I see he did an HTML version. I guess he had an HTML version of the assembled code. Can I just view this? There we go. All right, so that's it. See, he had this, you know, must be assembled with the Avocat or Avocet or Avocate ASM09. Anyway, this is exactly the same format that the BIOS was written in. Certain things like, you know, everything, all the directives are in caps. There's no colon after the labels. Certain things like that, which the Kingswood assembler doesn't like. So I was like, okay, this guy went through the pain of, you know, making it work. And I just took a look a little bit at what he did, and it seemed pretty straightforward. But in the end, I just went and did it myself. So with a bunch of regex and, you know, search and replace and all that, I was able to get the BIOS into a pretty good state. Here, I'll just just show it here. So yeah, this is the initial version, and then this was just one commit where it all changed. Let me show the diff here. It's actually 2 files, but let's say as an example of the kind of changes we're talking about. Yeah, so like all the things that were in caps became lowercase here. So all the instructions are lowercase. Like I said, labels, I had to remove the colons on the labels. It's just a bunch of like annoying changes to have to make. Oh yeah, one of the problems that I had, was this part of it? No. Yeah, and one of the problems I had was in the other file, in the include file, there was a problem of redefinitions because all the functions are defined here as includes. So all the names here have a mapping to their address, but they also appear in the BIOS routines, like in the other file itself. So it was complaining about multiply defined symbols. So I had to basically comment all this out. So anyway, after spending about an hour of messing around and figuring out what the assembler wanted, I got it to the point where it assembled, which was cool, right? So let me show what that looks like. So I wrote a little bash file called build here. So I call it, and then there's a bunch of parameters here. Like this here just says, I think this has to do, with writing like page headers so that you could print it, page 1, page 2, and all that stuff. So if you do -H0, it means I don't want any of those. And this here is kind of ridiculous, but you have to set a width, and if you set width 0, it doesn't actually work. So I just set a really large number, so I get no cropping, because it would just crop after a certain width. And then -T says, this is kind of cool, I discovered this option, which is generate a symbol table, but I'll get to that after. So basically, if I run my build.bat, it produces this bios.lst, that's this listing, and it's exactly the same code, but as you can see, we now have these addresses everywhere. Next to every single directive, every single symbol has an address next to it. This is the include file, And then, you know, here we go to the starts. It starts at F000. So there's the address, and then there's the code, right? And so now, when I'm debugging the BIOS, if I'm wondering where I'm at, I can just search the address. If I want to break at a specific point, I can just put a breakpoint at that address. It's really awesome. And yeah, and the other thing that I discovered was this symbol table thing. So I'm going to show you that. And here, because I said to generate it as well as generate the listing, it puts it at the end of the file under the symbol table section. This is really neat. What it does is it takes all the symbols that it encounters. So that includes like the ones that were defined explicitly with the equate directive, but it also puts like function names and stuff that it found, you know, like let's see here, init os ram, let's say, right? Init os ram here. This routine first, this is actually a function, right? And it's at F164. This here has now, it's in the symbol table. That label has this address. Now, why is that cool? My debugger has this kind of load symbols that I wrote. When I wrote it so that it would parse a file like this Vectrex.include, where I would just kind of look for symbol, name, equals, and then equate, and then an address or a value here. And that worked fine for the BIOS, but I found that it didn't work fine for, let's say, Mindstorm, for which I had the source and which compiles, because it works fine for only symbols that have an equate line. In the case of the BIOS, it happened to have this whole section where every function name had its own entry, but that's not the case for most, you know, most source codes for games, right? But now that I can generate a symbol table, if I'm so inclined, I can just modify my debugger to go ahead and parse that symbol table. So, you know, along those lines, I wrote a little batch file for generate symbol table, which will produce just a simple file called symbol table.lst that has that symbol table. So, for example, this is the symbol table for the BIOS, right? Similarly, if I go to Mindstorm here and I run generate symbol table, I get a different symbol table, and this one here is all the symbols that are used by Mindstorm, including all its functions, which is really, really cool. So if I just modify my debugger and load these two, debugging Mindstorm or any game for which I have source should be really easy. I haven't done that change yet, and I'm going to wait until I really need to, but it's definitely on the table. Perhaps even more interesting, and I don't know if I'm going to even get there, but I wanted to show this. AS09 also has generate source level debug information, right? So I haven't tried that one yet, but like, let's just see what it does. So I do -G and do that. That went ahead and generated this dbg file, which is some binary file. Now, I don't know exactly what format it's in, but you can see that, like, just quickly looking at it, it points to the the path to the ASM file, the source level file, right? This is a Kingswood source level debug information file. I mean, I could try to look for more information on this, but technically what this would mean is, I'm just looking a little bit at this. Maybe if I use let me use my hex editor. XVI32. And let's drag this guy here. Sorry, drag this guy here. So, like, I don't know, there's a bunch of names here, and then after that you have like some values here. So after, I don't know, this beg layer, we have 1, 2, 3, 4 bytes. So there's 0003, 9606. These are probably pointing to line numbers in the source file or something like that. Like, I could try to look for that, BEGLAYR. in Mindstorm C. So let's take a look. Mindstorm C. Let's open it up. B-E-G-A-L-L-A-R. What is it again? B-E-G-L-A-Y-R. Oh, no match case. Okay, there. All right, so this guy's at line 1074. So there's a cute little thing in here called a data inspector that might be able to show us. Unless it's written beforehand. Okay, so I'm not really finding it. Anyway, I'd have to know. I'm not sure. Is it really a line number, or is it an offset into the file? Maybe it's just a byte offset rather than anchoring with line numbers. Probably because it ignores comments or stuff. I'm not sure. But basically, if I was so inclined, I could parse this file and then have full debug info. Like, rather than disassemble my own every instruction myself, I could just display directly the line and the lines that come after and all that come straight from the source file. So just like in a real debugger, or write a debugger or something. So maybe this Kingswood guy did it himself. I'm not sure why he would have made a format like this otherwise, but Kingswood. I mean, I went to his site here. Let's see. So these are his assemblers. This is the one I was talking about, that I'm using, AS09 here. See, it just downloads it. Supports binary S records or Intel hex output file formats. Optionally generates debug information. Yeah, not sure. Not sure what. You know what? I can just write to this guy and ask him. Maybe he'll be able to enlighten me on what the deal is with that. In any case, let's close this. It's just cool. It's cool to be able to finally be able to assemble the BIOS and have that information for when I need it. Okay, so what does that lead me to? So yeah, what I wanted to do was work on the VIA, but I didn't really have a lot of time to read it. I have a few documents about it, and I'm not sure how exciting it would be to read this stuff on stream. I kind of wanted to read it alone and start preparing a plan for how to go about implementing this, and then kind of do that online. One thought I had for today is, I know for a fact that I didn't implement all the CPU instructions. Now, I don't want to go ahead and implement them blindly because I think that sucks. But what I could do is, since I know that my emulator does support loading cartridges, we could try just loading a bunch of different cartridges and see how far we get. Maybe we'll hit a bug. Maybe we'll hit an unimplemented CPU instruction. Maybe not, right? Like, depends on how far we get inside the game. But it could be kind of interesting to just try a few. So to do that, let's just make sure I got release with debug info here. I'm just gonna build. No, it's already built. Let's try again. Oh, yeah. I have to run CMake again because I reverted that change where I brought in the Vectrex file. So just gonna come in here, run CMake. I don't have my CMake set up to where I list every single source file and all that. I kind of just have a star.cpp in there, and that's why if I add or remove source files, I gotta manage, like, rerun CMake manually like I do. It's not really technically the right way to do it, but it's simple enough, so that's what I go with. Okay, so that's built. So release with debug info. So if I come in here, release with debug info, so there's the emulator. And if I, let's say, open a folder into my, I have a bunch of ROMs somewhere. Here we go. So I have, these are all the ROMs here. So let's just, I don't know, just grab any one of these, and I think I can just drag them onto it. Maybe not from here. Here. What I'll do is I'll open that here, and there we go. No idea what's happening here. Oh, okay. It looks like I got a crash right there. See, that's interesting, right? Very first one I try. So, like, yeah, I'm not sure that was a valid test, but let's try this. Let's do copy as path here. Let's open a command prompt there, and let's run Vectrexy with this path and see. Pull up. Oh yeah, it crashed. Interesting. So okay, that's really cool. So now let's try. You know what? It's because I'm running release, so definitely not getting assertions and stuff. I probably am hitting an assert and I'm just not getting it. So let's try and debug, see what happens. So rather than release with debug info, we'll try with the debug version. Vectrexy. Okay, debugging. I got an assertion right away. So here, let's do this. Let's take this path and let's put it smack into Visual Studio and see where we get. So I go into my debugging properties, set it as a command argument, and hit F5. You know what? You know what's happening, I think? Oh yeah, I know what's happening. Of course. Yeah, so the thing is that when Vectrexy runs, it wants the BIOS in the same directory, or in the current directory, not the same one, but in the current one. And I'm trying to run out of the debug folder, so that's never going to work. I need to run out of the folder that contains the BIOS. So normally what I do is I go here, and there's that BIOS ROM bin. So either I copy it into those output folders, which is one option, or I can just say from here, build 2017. Let's say debug, or let's try release with debug info again. Vectrexy, and then put, I need the path to the whole ROM. Okay, so there we go. So we come in here, and I'll need to set it up as usual. Turn off trace and continue. Okay. So far, so good. It's not crashing yet. That's a good sign. And I believe I have my change to make it run as quickly as possible. Let me see. Yeah. Yes. Yeah, there it is. Yeah, so this is the change that makes it run as quickly as possible. And here we see we're at 00B8, so that's in cartridge space. If I turn on the trace again, you can see that we're kind of going back and forth between Oh, that's something that's not super cool. I should be making sure this is a, displayed as, I should display this as a fixed width. Anyway, doesn't really matter. But yeah, so all of this here is in the cartridge space, and then after that, if you see an F here, it means that we're jumping into a BIOS routine. In fact, if we want to know exactly which one, let's load our symbols. Where is it? I have like too many tabs. Test. Did I close it? All right, here. So if I copy that into here, so yeah, now if I continue, try and see what's going on here. Oh, I'm surprised it's not showing. I'm just surprised that it's not showing here the symbol for this BIOS routine. It's super weird. Or is it? Oh, maybe it's not so weird. Because I did change the BIOS file. And now it's EQW. Yeah, EQU is no longer in caps. So yeah, so it's not even parsing that thing fine. You know what? I'm just going to fix that right away because that sucks. EQU. That's it, because I'm looking for this find. Is there an iFind? Yeah, there isn't, is there? Standard string.find. Standard string, find, ignore case. Yeah. You know what? Screw that. If tokens greater than 3 and we find this, or we find this, keep it simple. It's just for debugging anyway. Alright, so we built this in debug. It's built in build and release with debug info. And let's give that another whirl. So run that. Hello? Oh, it crashed. Why? Oh, sorry, it's the wrong console window, is it? Did I close it? I think I closed it. Okay. So build, release with debug info, Vectrexy, and then this path again to 3D Crazy Coaster. Okay, here we are. And this and that, and that. And now we run. So ostensibly I got my symbols now. We'll see. We'll see if I did. Okay, let's see. Turn on trace. Yeah, all right, there we go. So we can see now, you know, again, this is the game. And then whenever the game jumps into a BIOS routine, in this case, it's jumping into sound byte raw. That's not right. Oh, geez. What's going on here? Oh yeah, no, that's fine. Yeah, it's because I had to put these I had to actually comment these guys out. It doesn't matter. That's actually the name of the function, soundbite raw. Like, again, this is why I need to parse properly the symbol table. I won't have these issues. It's total hack, but here we go. It's like calling soundbite raw this BIOS routine here. It's got something to do with playing music or playing some sound effect. Yeah, so that's cool. Just gonna run it a little bit. Looks like it's like flashing the same thing over and over. So either we're in some loop here, or there's just a lot of code to run to do that. But I'm not getting anything here so far. So maybe I'll just run a few and I'll give them each like a couple minutes or something. See if we hit something interesting. Yeah, see, now we're in slightly different piece of code here. You know what I think? I think we're just on the title screen. If I had to wager a guess, and it's just playing music on the title screen. That's probably what's going on here. I can't be sure, but seems plausible. I should also fix the fact that, you know, the debugger is not printing this correctly. Like, I mean, we can see that part of my debugger is, right? And then if I step, instead of putting 00B9 here, it's just putting B9s, which is not super cool. So let me just fix that up right now in my debugger. So what am I looking for? Something like this. I think it's this here, isn't it? Yeah. It's that. Totally that. And I notice I can just kind of copy this here. What's the deal with the percent? Why did I put a percentage here? That looks like a mistake. I think it should be $% here. I guess I haven't hit this case a lot. Yeah, that's right. That's exactly right. It's $%. There we go. And we just want to, all we did really is introduce this 04 in here to say pad it out to 4 and put zeros. Make sure it's 4 with and pad with zeros if it's less. So let's build that. Take a look what that looks like. I have to quit this. And let's run it for a little bit. We'll break here. Beautiful. So yeah, we can see it's kind of switching between the game and the BIOS, doing that sound stuff. All right, so I'm satisfied with that guy. Let's try a different ROM. "3D Mindstorm." What's that? You know what? Forget Mindstorm. We'll keep doing Mindstorm. Let's try Narrow Escape here. What's that? All these different versions. 2D version, 3D. Okay, let's try the 3D one. So I'll do this. Oh, exception caught. Awesome. So this is probably a not implemented instruction. That's my guess. And I'm getting this, and I'm not getting what it is, probably because I'm not in debug. So let's try the debug build instead. And we'll take that same path, do it in the debugger directly. Let's see where this gets us. this will take a bit more time in debug. I've noticed it's significantly slower in debug than in release. There's just no optimizations, and there's a lot of code that needs to be optimized in the CPU implementation for it to be fast, and also in the debugger. All right. Okay, so I'm getting an is in range assertion here. We're trying to access, there's a write that's going on. Let's see if we can figure this out. So first of all, let's see what this looks like. It's trying to write to C7FF. Okay, so this is a write to cartridge space. And what's the problem here? The range, okay, so the range stops at CFFF. Oh, okay. Interesting. I'm just interested here because my range here is C800 to CFFFF. What is that? It wants to write to RAM. Let's see, in the memory bus, what do we got here? So see, a write to 7FFFF should have gone to the first device, which would be the cartridge actually. And yet, it looks like the device I got back. So do I have like a bug in my find device info here for when I write to the last address? It's possible. It's very possible. Because the second device here is RAM, right? It's kind of difficult to see it in debug because I don't have like names for my devices, but I know that that's the case because like RAM here, when it connects itself, it says connect me for the range C800 to CFFFF, and that's where we are at. Yet that's not the device it should have found. So this seems to be a problem here in my, super odd because I actually do a less than or equals to compared here. So what we'll do is let's put a conditional breakpoint on getting this specific address. We'll come here, we'll say settings, condition, I want you to break when address is equal to that, and we'll restart. Put that in my debugger and continue. We'll just wait to hit that breakpoint. Again, this might be a bit slow, so I apologize for the time it takes. One thing I'm considering is taking, like rather than use debug like this, just use release, but like disable optimizations on certain bits of code when I want to debug them. Something like that. Because I'm using CMake, there's like these 4, default configurations that it generates for Visual Studio. It's not like super easy to manipulate them or make them the way you want with CMake. What I would normally want here is some kind of hybrid, like a release, like a debug, but with certain optimizations enabled. which I guess is what release with debug info is, but it's like I want debug with release, kind of the other way around. Bit more symbols. I guess it would be, yeah, it would be like release with certain optimizations disabled, so that it's still fast but easy to debug, or easier to debug anyway. Okay, so this looks like it's taking quite a while. In which case, it might be faster, because that's the thing, conditional breakpoints can be quite slow. So I'll do my other trick, which is to hack in a call here. And do like, is it 0x C7FF. And I use a printf just to make sure it doesn't get optimized out. And this way I can just put a normal instruction breakpoint, which is faster. We'll disable, actually we'll just remove this one. All right, and we go. Okay, we should be hitting it soon enough. Okay, here we are. So let's see what happens. We go into find device info. So address is less than device is zero's first address, which is 0. And for all devices, if I'm less than the second, so there we are, less than or equal to, which is 7FFF. Oh, did I see this wrong? It's C7FF. Right. And then the next device. Okay, so it totally is. I just misread it. Okay, so it is trying to write to RAM. So why is this a problem? Wait. Oh, okay. Oh, it's trying to write to unmapped memory? So that's the problem. It's totally unmapped. Okay, I don't have a case to capture unmapped. Yeah, kind of like a weird. Okay, I assume in my find device info that that I have like my devices fully cover the address space, which it doesn't, right? Like, 0 to 7FFF, the next range is here, but that's unmapped, meaning there's no device that's supposed to be plugged into that. And then after that, I've got RAM, and that covers the, all the rest of the range is all fully covered. There is also this illegal range that's not covered. So it's like what I would need to do is, there's a few things here. Like, first of all, why is the game writing to C7FF? Is that correct? I don't know. I could check. I could run it in that other emulator and see if that write ever occurs there. And that's the thing, right? Some games may be illegally writing to unmapped, or worse, like doubly mapped illegal ranges. And as an emulator writer, I need to kind of handle that, right? I need to say like, well, if it does, like on the real hardware, if it does here, don't do anything. Just like kind of let that slide. Maybe just report it or something for interest's sake. And then for this case, if it ever happens, I think I would need to like pretend, like kind of reroute the write to both the VIA and to the RAM. So I'm hoping that's not the case, that games actually do that, because that would be crazy. So, okay, so what? Is it a bug that the game is writing there? So why don't we try, since I have it and I know it works, let's try the other emulator. Vectrex, which if you caught the last stream, you saw me building and running this guy. Okay. I think I still have some breakpoints in here. No, nothing interesting. Ah, here, read. Read and write. So let's set this guy up similarly. The way this emulator works is you pass it a path to a cartridge, but you have to say -C to tell it that we're giving it a cartridge. Whoops. So we give it the same path. Okay, so it's saying it can't open it. Why? Why? What's wrong with this? Does it not like spaces? So I'm getting this error. Cannot open. So there's two places here. If ROM file is none, let's see here. What are we getting here? Okay, that's rom.dat. Okay, so what was the other guy? Here. Oh, that's the cart name. So not the ROM. Okay, so this game calls the ROM the, which makes sense there. The real ROM here is the BIOS ROM. Okay, here's the cart. So there's cart name. So what's the problem here? Oh, look at that. Got chopped. Yeah, it tries to do some handling in there. Skip any blank space. What's it doing? It wants a 256 character string. Why is it bothering with all this? Skip space. Okay. So I think that's what it is. That's it, stopping at the first space. Doesn't like spaces in the name. It's not handling quoted strings, basically. So, I mean, I'm not gonna fix that. Like, let's just make this work. I'm just gonna kind of copy this somewhere. I'll just remove the spaces. Okay. What is it didn't like this time? Everything looks right here. It's because I got null back. temp Vectrex ROMs 3D narrow escape. That's you know what? Let's make it really simple. Narrow. I wonder if it's the quotes. Could be a, yeah, I bet you it's the quotes. Okay, it worked now. Yeah, so let's see. Okay, we're in write. I just wanted to step in. So this is the actual write function. And what I wanted to do here was say, we're looking to see for a specific write. Let's do the same thing. Start all over. Take that out. Okay, I don't need this, and I don't need this, and let's just run. Oh yeah, cool. So I see on the OBS I left my capture for the Vectrex output, so that's cool. So you're seeing this. Oh, and look at that. It totally writes here. So it's not a bug. I mean, it's a bug in the game, right? See? And like in this emulator, it just says, well, I mean, that's just totally a useless range. Nothing to do with that. Let's just skip it, and everyone's happy. Oh, okay. Yeah. Interesting. That's really interesting. In fact, that's actually super cool. So Visual Studio just detected at runtime that data is being used without being initialized. Like we're returning data here because it's declared. We never went through any one of these branches, and then we're returning it. So yeah, it'll return whatever garbage is in there. Wow, that's really cool. That's really helpful. So, okay, so what that tells me is it's not a bug. So what I'm gonna do is I'm gonna create a device, like a kind of like a fake device that will just be there for the purposes of catching those kinds of writes, and all it's gonna do is it's gonna report them. You know, illegal write to this range, and then we'll move on. See how far we get with that. So let's go to our memory map. I'm going to do one just for this unmapped range. I'm not going to bother yet for the dual select range here because we'll see if that ever happens. But we'll start with this guy. So we'll call it like an unmapped device or something, or unmapped memory device. Let's start by just writing it in main here somewhere. Class unmapped memory device, which is an iMemory bus device. Public. So like all the other ones I have, it's going to be nice and simple. We just need to have an init function and a read and a write, and that's it. And here we're going to take memory bus, and we're going to connect, and we're going to say connect myself to memory map unmapped range. And if we get a read or we get a write, we'll just, for now, we'll print it here. So we'll say read from unmapped range like that. And similarly, we'll say write to unmapped range at address of value percent 0 to x $sign% of text at address this. We'll say value. Okay. I'm going to move this into another file later. I just want to try it out first like this. It's always faster to develop without having to create a bunch of files and stuff. Okay, so I've got the CPU, and let's add it somewhere in here. Auto unmapped. Follow the pattern I've got going here. We want to initialize it. Okay, so that adds to the memory bus. That's it. So let's see if that builds. All right, read must return the value. So we'll return 0. Okay, so now we should actually, I'll just put a breakpoint in here. So yeah, see, it's interesting to try different games. We detect other parts of the code that need to be tweaked in the emulator. Still not like unimplemented CPU instruction though, which is what I was kind of hoping for. All right. So this time it should find my device. So let's see here. Yeah, so 8000 to C7FF, that looks like our friend. Yeah, that's the unmapped. So it should pick that device this time. And then it calls write. There we go. We get into my function here. I forgot to put an actual breakpoint there. We end up with a printf, which did not get flushed just yet, but that's okay. We hit F5. Oh, another one. So this game is just writing all kinds of fun stuff. Oh, and even a read. And then it actually tries to write to ROM, which is not allowed to do. Yeah, even this, maybe I shouldn't assert and I should just print kind of thing, It's just that it's been really useful for, it's because until I'm certain that my CPU implementation is solid, I don't know if an illegal write is because the game is doing something bad, which seems to be the case here, or it's because there's something wrong with my CPU implementation. So it's like not 100% clear to me, when I should do that. Maybe just for now, I'll just change this into a printf and see how far we get. So illegal, and actually, yeah, this is the BIOS ROM, right? Like, seems kind of fishy that it would write here. Legal write to BIOS ROM at address. Missing a /n. Okay, so let's see. We're running now. Should hit one of our breakpoints soon. Okay, so there's one. So yeah, I really wonder, like it's trying to do a write to FEE8. Seems rather surprising, right? Like I wonder, now I'm wondering, you know, does Vectrex see the same kind of write? So let's see. Oh yeah, just this runtime check here. You know, let me initialize data for Vectrex here to 0, so I don't get that failure. Huh. Interesting. There were these like kind of, I don't know if my mouse is, yeah, it's not really. But there were these like weird lines. Oh no, there they are. Those weird lines in the corner. Yeah, there we go. It does try to write to the BIOS. And of course, that's totally ignored. Wow, multiple times. Jeez. Yes, I don't know about this game. It's just a weird game. Let's see if it even works in Vectrex. Maybe it's just a bad ROM. It's like now it's like stuck. It's all black. Okay. I am going to assume that this is a homebrew ROM and looks like it's not working in this emulator or something. I don't know. All right. So my emulator seems to be working for that ROM. I'm gonna give up on this one. Let's try a different ROM. 3D narrow escape. It does say 1983, so it does seem like something valid, right? Let's see. Vectrex. Oh, it's a real thing. So I'm not sure why it didn't work. Oh, it requires a 3D imager. Oh, it's one of those ones that you need a 3D imager, which are these really cool VR goggles that was made for the Vectrex. Okay, so I don't know. I guess, I don't know. Okay, so here we start to see like homebrew ROMs that were made later, like this one in 1996. Let's try this, Animaction. It's a light pen thing. Let's try it. Let's try the second version. Okay, so I'll try it with my emulator, see how far we get. I'll do release with debug info just to see because it's much faster. And we'll see how this goes. Animaction, yeah. Okay, so we do get an exception, so that's cool. That's interesting. What is the exception? Oh, is it? It's illegal. It's an illegal instruction? For real? You know what? I can't trust where we are. Let me just rerun this in debug. Let's see. Let's see what animaction does. So let's look. What is animaction? Animaction Vectrex. So, wow, this looks like a super cool game. Like a light pen and everything. Okay, yeah, it's like going super slow. Whoops. Let me just like lower the... I think I can't be running such a high quality YouTube video while streaming and while debugging and everything. It's like killing my CPU here. Okay, there we go. Yeah, this is pretty crap quality though. Oh, okay, I think I remember this. It's some kind of like vector drawing tool, and you can actually animate stuff. Like this guy's drawing a face. All right, pretty cool. So where are we here? CPU op address illegal. So this is actually trying to execute an illegal instruction? Could that be? Okay, so what I'm going to do to figure out if that's really happening, let me go to my debugger and see how many instructions we ran. So we are at looks like 3,362,968. So let's start all over. What we want to do is we want to step until, let's say, till here, then we'll turn the trace back on, and then we'll continue. So we're stepping that many instructions, then we'll end up turning trace back on, and we'll continue. And I just want to kind of see what the code looks like. It'll be really interesting to see what happens here. Okay, there we go. So where were we here? Can we get an idea of where we were? So obviously we're like in the BIOS somewhere. Yeah, this doesn't make sense. I think this is a bug in my emulator, because I mean we're clearly in valid code here, right? In fact, now that I have addresses for the BIOS, I can just go take a look, which is really cool. So let's do that. Here's the BIOS listing. And there we are. Branch if plus. Is that? Here I've got branch if plus. I'm disassembling this to branch if plus F8. And then I'm complaining that this is not valid, but this is totally valid. 2A F8, that is the instruction indeed. Let me see my debugger where we're at here, right? And you know what? This could also be print op, disassemble op. Yeah. So let's see, which operation are we disassembling here? Okay, so it's FFE1. That's where my program counter is pointing at. FFE1. Why FFE1? You know what? It's possible that maybe my branch if plus is producing an invalid. No. Yeah? Yeah. Yeah, like maybe what my branch if plus is supposed to branch to like F4C7 here, but somehow his gotten the C, like it's setting the, what do I want to say here? It's setting PC incorrectly to this weird address, which is why like we've got some garbage here. That's what it looks like, because it doesn't make much sense that our PC would be FFE1, right? Yeah, it doesn't make much sense. Let's go to FFE1. I'm sorry, FFE1. Yeah, nothing even mapped there. Like FF, I mean, we're like, oh, well, we've got some stuff here. But why would we be here? You have FFE. No, sorry, this is FE. Looking for FF. FF ED ED. Yeah, see, like it's somewhere in the middle of this. Like E1 is somewhere in here. Something totally went wrong, and so it looks like my branch if plus must have done the wrong thing. So what we're going to do is we're going to put a breakpoint right on this little address there, F4CD. And then we'll continue. So let's restart this guy. This is when I'm so happy to have a good debugger. I'd never be able to find these otherwise. Okay, so should be hitting that guy soon. Breakpoint hit. Okay, so before I continue, I'm going to set a breakpoint in my actual Visual Studio. Just give me 1 second here. Okay. All right, so let's put a breakpoint in the CPU execute instruction. I'm going to step. So here we are. So our current instruction is F4CD, right? So if we just go check here back in the BIOS listing and go to F4CD, man, I'm so glad I've got this. So this is the guy that we suspect went wrong. That branch of plus. So it's relative mode addressing, ostensibly. I'm just gonna double check in the opcode table here. So we're looking at F4, sorry, no, 2A F8. So yeah, so 2A is a long branch. Is that possible? No, sorry, it's this one here. It's not, it's the page 0 version. So branch if plus, and it's relative. So this is a relative mode instruction, which means that the next 2 bytes, F8 would be the offset to take. Is that right? Yes, because this would be negative, right? You see? So that's probably where I have my mistake. I wonder if this is similar to the bug I fixed the other day, just the other night. It's very possible. Yeah, it's very possible. So like F8 here, you know, it's a negative value. How do I show this as? Yeah, so it's -8 if it's a byte. So -8 means, you know, go back 8 bytes. So it's like 1, 2, 3, 4, 5, 6, like 1, 2, 3, 4, 5, 6, 7, 8, which brings us effectively to this instruction here, which is exactly what's, unless I can't count properly. Oh, no, sorry, that's it. To this instruction here, which is 8 bytes prior. So let's see. My guess is we're not calculating, we're not producing that -8 properly. So let's see what happens. So CC negative, up branch. So read relative offset. Well, that's not too complicated. So that's right, it's a negative value. -8. Oh, so here the condition function wasn't true, so we're not actually making the branch. I suspect that there's probably multiple calls to this one, but it's weird because it means the code looks like it would have done the right thing. So we're at F4CF now, which is the next instruction. So let's continue. And then we hit the breakpoint again. So okay, actually, so we want to know if we're plus, right? So branch if plus, we go back here. That means that the negative flag is not set, which is the case now. I guess the negative flag was set before. So this time around, we should end up in this op branch in this here. So let's re-enable our breakpoint in execute instruction. We'll step. The offset -8. This time condition function is true. Let's drag PC here and make it hex. So we're at F4CF. Okay. F4C7. Okay. Okay, so far so good. Okay. Disable this breakpoint. So that's not the problem. Okay, so I guess I was on the wrong foot here. So let's disable this breakpoint. Okay, so we died again. Maybe I should have left the trace on, but okay, let's try this again. Let me remove my breakpoint here. I just want to take a look again at the trace. Okay. All right. So we're getting this illegal instruction again. Let me check again what our PC would be. So the thing is that right now, it's failing when I'm trying to print the op, right? And yeah, so it means that the last instruction screws something up. Ah, yeah. Yeah, that's right. I'm not flushing the output, so I don't exactly know where I am right now. Yeah, I've run into this before. The problem of my trace output, because it's buffered, when something goes wrong, like an assertion like this, it doesn't actually flush. So what I would need to do instead of assert here is, and I keep telling myself that's what I need to do, is I need to like throw an exception and catch it, so then I can go ahead and flush all that has happened up until then. Did I do any other throws? This thing is that this kind of exception, I don't even think it can be rethrown, you know, like I can't continue with it. Like even if I have a try around it. What's the right thing here? Oh, I have an idea. Rather than doing buffered output here, really simple. We'll just turn on color here. It's kind of a hack there, it's a little trick, but if I do that, it disables buffered output. So let's just do that for now. I really do need to fix this properly though. Like I need a proper solution. I gotta stop asserting, because asserting is nice because it gets me exactly in the right place. I can still say throw exceptions. I can create my own kind of debugger exceptions or whatever, CPU exceptions, and then I can say in Visual Studio, break as soon as this exception is thrown while I'm debugging. So I get the same benefits as the assert, but I also get the debugger catching it and flushing the output. So here, see, I'm in color, so it's actually a lot slower than buffered output, but it means that I can now see exactly where we are. So we were not where we thought. We're here. FFE0. Okay, so let's see what's going on. Clear all this. This is my big disassemble op is here. CPU registers. What do we got here? Let's turn this into hex. PC FFE1, which makes sense. It would be the instruction right after FFE0. So now let's go take a look at FFE0 in the BIOS. The BIOS listing. Huh, not there. Okay, so oh, that's interesting. So it's here the problem. See, like we're actually in the game, in the cartridge. Jump to 0020, and then at 0020 it does a branch to BD, which would be a relative branch, I suspect. Branch always, and BD is ostensibly minus 67, which means that, you know, if you're at address 20 and you subtract BD, you'll end up in ROM somewhere. Could that be right? Doesn't make sense. me just make sure. Yeah, BD is minus 67, right? And PC would be, so PC would not actually be 0020, it would be 0022 because it's 2 bytes by the time it executes this. And so it's minus 67 from that. So 0022. So BD. Let's go to, there we go. So what we're saying here, 22 minus BD. Oh, what just happened? FF65. Is it 20? Does it really subtract from that? It doesn't make sense, but okay. FF63. Actually, even my display here is totally off, right? It should only be the last. I don't know why I'm displaying. I guess I forgot to put a percent here, %04 on this. So it's displaying it as an integer. That's kind of confusing. Let's see if I can find that in my debugger. %04. Huh. Ah, that's why. It's because I have int here. Okay, so what's happening is I have auto, so next PC ends up being an integer, and then integer is wider than 04, so it's printing it like that. Okay. In any case, it still doesn't make sense. That's FF63. I don't know why it's why I have DF here. I need to test. I need to actually put a breakpoint here and see what's happening. I have a lot of questions in my mind, like, should we even be here? You know, like, does the game really get to 0020, and does it make sense that it wants to branch here? Like, are we just interpreting these 2 bytes here incorrectly? Like, is this data? It's possible. So I could try to, I could see if Vectrex gets there. Or I can just run the Vectrex CPU in my emulator and see if we get to the same place. But before that, I'd like to debug this, just make sure this is doing what I think. Because I'm also thinking, so I did this here. What am I doing in my CPU? Yeah, I'm not doing this at all in the CPU, that's fine. So here I'm going to put UN16T. I might have to cast this because it's going to complain, it's going to warn. Let's see. Yeah, warning, cast from int to UN16. which makes me wonder whether this size would really just not be an integer, but rather just a uint. What should it be? No, I'm just gonna cast. I think that's the right thing here. I mean, because this is kind of hacky anyway, what I'm doing here. I'm trying to figure out the next instruction, and I know that the size of the instruction is always small. I mean, technically, it should just be like a uint 8t here. Could also do that. Make the table a bit smaller. I won't worry too much about it. Or should I worry about it? Let me try. Uint 8t for the size. Because one good thing here is that if I ever write a value that's too large, because it's all compiled, this is all like static data there, the compiler will warn me about that this is too small for the value. So that's safe. Now I just made it unsigned. Is that a problem? Shouldn't be. No. That's good. Okay, and the next thing I wanted to do was, I wanted to debug that instruction, but I just lost what it was. So let me just run this again. Okay, so now we're tracing. Okay, so let's go back to our trace. So let's see if it makes sense. Oh, I thought this would be fixed. Oh, I think I have a few other ones that do the PC plus offset thing that suffer from the same problem. Plus offset. No, this should have been fine. Try it again. Debugging is nothing if not trying over and over again. We'll get there. Why is my breakpoint? Oh, right. Here, just want to see what I get here. Comment. So I get F for EB here. I'm just looking to see why at some point it ends up formatting it into some large value in the comment. Okay, it's like two different things to debug here. I've got like this weird, this weird printing here that I don't understand. Okay, so let's just start by breaking on 0020. So break on that guy. Color trace like that. And we'll see what happens. So let's hunt down this bug, see what's going on. Colorful output forthcoming. There you go. Okay, so breakpoint hit. So this is the interesting bit, right? Let's like there's a few things I want to do. I'll put some breakpoints here because on this guy and on this guy. And let's see what happens in the CPU now. I think I have one here, yeah, execute instruction. So let's step this guy. All right, because we disassemble first. So yeah, so here, right, like, yeah, weird. No, that's it. 0020 plus 2 would put me at 0022. So that's what I was thinking, right? 22. And then my offset is BD, right? Okay. Okay, so what? And what, like, so why did this get promoted to integer? So offset is a char. And next PC is an unsigned short. So what? Unsigned short plus char gets it promoted to int? Why? Does that make sense? Promotion rules in C and C++ are always a bit strange. To me anyway. This has to do with the signed unsigned thing. I would have thought that it would be promoted to a signed short. And like, why? Okay, yeah, right. So what if it had been same thing, right? If it was a short. Why when I add two unsigned shorts I get an int? It's because it overflows? No. What am I missing here? Like even if I add next PC to next PC, I get an integer. I thought adding two types of the same type would produce the same type. But no. Okay. That's fascinating. 20 years of C++ and I still don't know some of these basics sometimes. Okay, so I'll fix those after. Well, now I want to see what actually happens in this instruction. So we want to do a branch, sure. We read the relative offset, which is -67, and then we actually go ahead and modify PC, which is currently 0x22, yeah. And it becomes FFDF. Minus BD plus 0x BD. Does this make sense? PC was 0x, it was at 0022. Then we added BD. But we want it to be signed. Like that. So -33. And then -33 is that, yeah. So, you know, it looks to be doing correct, like the code looks to be doing the right thing, but it doesn't seem to make any sense that we'd end up there. FFDF, which, as we saw in the BIOS listing, it puts us in the middle of this string here. Like that's 2, 3, 4, 5, 6, 7, 8, 9, A, B, C, D, E, F, CB. Was it CB, the next 2 bytes we saw? 4D. 4D? Oh no, sorry, this is a string. I would need to look at the ASCII values. Hey Repnop. Repnop writes, hey, apparently my phone didn't alert me that you went live. Are you uploading the vids anywhere? Yeah, man, I'm totally uploading them to YouTube. I have a link somewhere on my page here. I can share that with you. Hold on a sec. Yeah, I'll post it here. So, yeah, every time I finish, I end up uploading my episodes. Much like Ferris does. He'll binge them. Thanks, man. I hope you find them interesting. Today's stream is, well, it's interesting, but yeah, getting stuck on a couple of bugs. By the way, what time zone are you in? Okay, you're EST. All right, so same as me. Yeah, you're in the US. I'm in Canada, Montreal. So you just joined? Guess you were looking around. If you want, I can give you a. I don't know if you're gonna stick around there. I can kind of bring you up to speed on what I'm tackling. Repnop says, "Yeah, I wanted to pop in and say hi. Going to bed soon though." All right, that's cool, man. No problem. Thanks a lot for saying hi. Maybe next time you'll actually catch. Do you actually have the notifications enabled in what's it called, in Twitch? Because I noticed, like, when you follow people, there's that little option, you know, to like, hey, notify me or not, and it's like sometimes like default on and sometimes default off. I don't know how that works, but anyway, yeah. So I'll just let you know where I'm at. Basically, I'm at a point where the Vectrex emulator is able to execute like some 80% or so of instructions, which seems to be like the core 80% or so that games are using. At least that the BIOS and the built-in Mindstorm game are using. Now, I hit a point where, you know, things seem to be running pretty well. I think Mindstorm is running, but I can't see anything because I don't have any graphics implemented. So I thought maybe next up will be rendering, which is going to be cool. But I need to do some reading. I don't want to read docs on stream. I think it's pretty boring for people. So I'm going to read off stream and kind of prepare, you know, some ideas in my mind for how to implement it. So tonight I just wanted to instead try some different carts. So I have a bunch of ROMs for like a bunch of Vectrex games, and I'm kind of going through them and seeing like how far does my emulator go. And one of the things I suspect is I'll hit maybe a couple of those unimplemented CPU instructions, you know, or find other bugs in my CPU code. So basically I'm running this one right now, like I'm pretty much near the top of the list. This one called Anim Action, which is pretty cool. It's this like Vectrex game where it came with like a light pen. I wonder if I can find like a better video, because the one I found before is kind of crap.
This light pen was developed by John Ross, the same guy that also developed the 3D imager.
Okay.
Interestingly, the light pen was marketed as a unique learning tool, and I guess the idea was to give...
Here, okay.
So you see now a bunch of dots, and if I press the button 4, those dots are connected.
Where's a bit?
And this could be a cat, I guess. And you can also use.
So this guy is like drawing using the light pen directly on the Vectrex.
You were drawing before you connect the dot.
I'm just gonna mute it. You can see him drawing here. So it's pretty amazing, right? I think it's pretty amazing. It's 1982, right? 1982-83 is when the Vectrex came out. And it had a light pen, and it had 3D VR goggles. So Repnob says, "That's sweet. I've never heard of the system before your stream mentioned." Yeah, it's not a super well-known console, because it came out right at the time of the crash, the video game crash, and so it like totally got like it got destroyed, like all the other ones that were out. There were so many game consoles and systems that could play games, and people didn't know what to do, and the Vectrex came out, and like also it was kind of expensive. I think I read it was like, I don't know, $400, and I think that was like then, so it's like super expensive, but it was a pretty cool piece of hardware. And what happened was, because of the crash, like they had made too many and no one was buying them. So a few years later, by like 1985-86, they were selling them for like $50. Yeah, pretty pricey. And like, so my uncle ended up buying a couple of them and gave me one. So I have one. It's I'm gonna take it out at some point and like kind of set up a camera on it, and like play a couple games and show stuff on it, because it's pretty cool. But I mean, there are a lot of, this guy here in particular, this Vectrex Rolly, he has a ton of videos that show off the different features. This guy got his hands on all the peripherals, including the 3D goggles and stuff. Yeah, this is like epilepsy flashing going on here. But anyway, so yeah, it's a really neat console. Like I took it out last year and had my kids play games on it. And they're kind of young. Like I think my son at the time was 4 and my daughter was 7, and they were totally hooked. They were playing. But there's a lot of cool arcade style games. One of my favorite ones is called Scramble, which is like just a kind of side-scrolling shmup. And yeah, so because I grew up playing this system, I kind of want to emulate it. It's not too complicated a system, but the interesting bit is the vector graphics. So yeah, that's why I'm looking at it. And also they're kind of rare now and expensive. Like if you look up on eBay, just get a kind of idea for how much they cost, like how much people are selling them for. Yeah, so it's not surprising to see them being offered at the same price they were selling at initially in like 1982. So like 400, here's $500, but you get like a nice 10 games with it, which is super cool. An HP 3000 controller, I don't even, whatever that is. And people are buying them, right? So that's kind of cool. Another interesting part of the system is like, it's a full system in one, right? You've got like, when you bought it, it came like this. It's got the screen, and it's got the built-in controller. You pop in carts on the side, like on the side here, and there's these. Every game came with like an acetate screen, like a kind of see-through. You would kind of pop it into these grooves in the corners, and it would add color. Because the thing is there's no color, right? It's just white, and it has different intensities of white, but that's like it, right? But through this like fixed color scheme acetate thing you'd put on top, you'd get some color in the game, and it was pretty interesting to see like the different kind of ways they came up with putting color on there. Some of them are really boring, like I think this one here, yeah. Actually, some of them are cool. Like I think this guy has a few here he's gonna show. Yeah, so here he's showing the Vectrex and the screen. I think he puts one on here, yeah. See there, that's the kind of thing Mindstorm had just a kind of grid on there. This was kind of basic, but some of them had really nice ones. So I have a few, like mine are pretty good. I have one that's a little bit damaged, but because they kind of got damaged if you kept putting them in and out, eventually they'd kind of wear in the corners and stuff, or where the tabs were. But yeah, like, yeah, it's really, really smart. You know, like, damn, it would cost a lot to put color. I actually read that the developers wanted to add color, and it was too expensive. And like they were actually working on a second version of the Vectrex that supported color, but then the whole project got canned because the first one wasn't selling well. So apparently there's plans out there that they released for that kind of thing. So okay, so that's the Vectrex, right? It's really cool, and I was wondering if I could show you like another cool acetate in here. But anyway, it has Berserk, which is some kind of arcade game as well. See, there's this little guy, and you're walking around shooting bad guys, and little maze, and I mean, you know, it's not NES or anything like that. You know, eventually it's just scores, you know, high scores and stuff, and there's no save ROM, or at least I don't know if there's any games. I read somewhere that there might have been carts that had writable memory on it. I don't know if it was battery pack though. I doubt it. That would have been pretty expensive and kind of a novel idea at the time. So anyway, okay, so that's that, right? And so what I'm working on now is I have this debugger. It's a trace debugger, so it allows me to like just show what instructions are executing, and I disassemble the instructions and I show what they are, and then I have something like this comments section where I, you know, try to output useful information about the instruction. And what it looks like is happening is I'm running this game, right? This anim action, the animation thing with the light pen, and I'm getting to a point where ostensibly I'm in the cart, and the cart is at address 20 in hex. So when I say in the cart, what I mean is like in the game address space. Because anytime you see 0F, like whenever you see F as the first letter of the address here, this is BIOS routines. Because like unlike the NES and much like, you know, computers, it actually had like this built-in BIOS with a bunch of routines, like a bunch of functions you could call, which were useful to like, you know, move the vector beam in specific places to draw, and to pull input, play sound. So they just had like this BIOS written with a bunch of functions. So whenever you see like an F here, we're running in the BIOS. And when you don't see an F, like for example here 0, well 0 is in the cartridge address space. And since I'm running a cartridge, it means that here we're executing code in the cartridge. So ostensibly we got to a point where we were at 1E. It decided to do a unconditional jump to 20. And at 20, it decided to do a branch always, to like a relative branch of BD, which is a bit weird because it's actually a lot weird, because it would mean that here we are at 20 in hex, and we want to add an offset of -67, which would put us at FFDF. So like we kind of underflow our program counter and end up in the BIOS's address space. And in fact, we end up in the middle of some string at the end of the BIOS. And I know that because I have the whole BIOS here disassembled with all the addresses, and like FFDF ends up like somewhere in here. Somewhere in here. Actually, yeah, I was looking here. 4D. Is there a 4D in here? Is it just like missing stuff here? I don't understand. Let's see. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. Did I count that wrong? 27. Yeah, 4D is M, you're saying? So probably the M in the middle. Yeah, I suppose so. I just wondered what is this string here, you know? And why don't I see 4D in there? I mean, this is the disassembled output, right? So it's possible that it's not showing the whole thing or whatever. Yeah, that's probably likely. So, and okay, so let's say M, and then, yeah. So let's say it's M. Let's say it's landing here, which probably makes sense, right? It's like D2. Let's see, 2. So this would be 2 here. 3, 4, 5, 6, 7, 8, 9, A, B, C, D, E. And what did we say? E, F. Anyway, maybe I'm off by 1 there, but anyway, good enough, right? So anyway, that's totally garbage. I don't expect this to be correct. I don't think it's likely that the game was going there. So now we're like executing, the CPU is interpreting this as an instruction, which is why it's doing this test A, and it's in fact an illegal instruction when it's this here. So actually, no, sorry, that one's fine. It interprets that one as test A, and then the next one at E0, okay, is also fine, com A, so that's 43. So does 43 actually correspond to C? Yeah, for sure. Like this is like, you know, it's in the BIOS. It wants this, right? It's going to use it somewhere for sure. It's data. This is data, right? We got this here. And you know what? This is probably like, Carsoft is like probably like the name of the company or some person or something. No, 4C is L. Okay, whatever. I don't know. There's L in there. I don't know. Bit weird, right? 4D, 4.3. The other thing, though, is it is possible, although I'm not sure, it's possible that it's not using ASCII to look these up. I don't know. I'd have to look at how the assembler works. Actually, could I look? I guess I could look. You know what? Just give me a second. Let me open the binary version of the BIOS. Yeah, I could totally do that. Here's the binary version here. I'm going to open this in my hex editor. Okay, so that's the BIOS here, and we want to jump to, well, let's go to FFD2 as an offset. FFD2. Why? Oh no, so that's it. FD2. Okay. So there's 4B. There's the Carsoft. We can see it over here, right? And we were doing 4D, 4.3. So I can see it here. 4D, 4.3. So there you go. So 4D, 4.3. MC. So why were we looking at 4C? Is that just me who said 4C incorrectly? I guess it's 4.3 we want to look at, right? 43. So yeah, so 43 is C. Okay, so it's totally ASCII, right? So yeah, we're interpreting M, and then we're interpreting C, which happens to be com A, and that happens to be fine. But then we're gonna go and interpret BC, I think, as some kind of garbage. If I step here, yeah, and there we go. We got like some illegal. We're in like some kind of illegal addressing mode. This is like, what the hell is this? I don't know what this is, right? My CPU implementation wants to disassemble this guy and is like, wait, this is not a valid op. See, like here. I don't know if you can see it, but my opcode is 66, which, why is it 66 again? Why is the opcode 66? Oh no, sorry, is that 42? Sorry, because I was looking at it in decimal. Yeah, so it's 42, which is that next instruction, right? So saying, okay, well, I've got 42 from my table here, and that's some illegal instruction. Like if I look at my CPU opcodes, um, 42, sorry. There we go. So in my table, 42 is illegal, and that's why I hit my assert. So yeah, like, anyway, we know, right? We're running data as code, and that's gonna fail. And so my question is, you know, what's going on here? Why am I ending up here? Something's wrong. So I have a few different avenues that I explore when I try to figure this kind of stuff out. What I did last stream, and it was super helpful, is I kind of hacked in the CPU implementation from a working emulator, and then I run it through with my debugger, and I kind of output with the same trace, and I compare the trace against mine and see like what it looks like. So I can try and do that. It would be interesting to see if, you know, if it even hits the same place. So let's do that. So I'll go to so I'll go here, and this is the commit where I did that. I'll just cherry pick it back. So what this change does, and if you do end up binge watching my streams there, you'll my videos there, my streams, you'll see that I did this last stream. But what it does is this here. I added this like hack, which was use Vectrex CPU impl, which if I define it ends up like including, this is the header file and C file for the Vectrex 6809 CPU. And I've barely looked at this code, by the way. I do consider this like partly cheating, but I'm like, if I like cover the screen enough and don't pay attention to the code, I'm like only cheating a little bit, right? But the thing is that it's like I said last stream, I don't have many options to figure out when things are wrong. Like I spent a long time, and I was able to find a lot of bugs by trying to understand what the code is doing. But if I don't have source for some of the games like this one, it's a lot of time wasted. And I don't have test ROMs that were written for the system, so it's difficult there. And I don't have a, you know, SD based cart to put into my Vectrex so that I could like write my own test and see what how the hardware acts. So I have like a lot of things going against me here, right? So repnop writes, yeah, I had to look up code for my Game Boy emulator, mostly for flag stuff and graphics. Yeah, exactly, right? Like, you know, you got to decide where to draw the line. You know, do you want to spend an inordinate amount of time trying to understand and reverse engineer the disassembly for the game that you're looking at, or you know, just kind of compare against a baseline that you know that works? And that I think ended up being the right strategy. So it's very little code because it's really clean, what, you know, the Vectrex CPU implementation, and I just shoved it into my CPU implementation, which mainly consists of like, you know, in my init call, I just make sure to hook up the read and write functions that it wants to go through my own memory bus read and write. I call its reset instead of mine. And when execute instruction is called, I call its execute instruction instead of mine. And then I have this one function from my CPU that returns the set of CPU registers in a structure. So in the case of using Vectrex, I have like a static here that I just populate all the values from external versions of its internal registers. So I just kind of copy them all into the structure and return it. And then that's enough for my debugger to be able to execute through it and display values with it. So it's kind of cool because like I just flip one flag on and I run my own emulator, and I have my disassembly, no, my trace and my debugger is always the same format, so I can totally diff the two, right? So let's give this a whirl. Let's try this. Let's go turn it on, first of all. Vectrex. So I'll turn it on. Build. So now we're going to build using its CPU implementation. Oh yeah, I need to rerun CMake because I just added a C file in there. Okay, so let me go into, sorry, cd build CMake. All right, so that's going to add the C file that's missing to my project. Repnop says, yeah, that'll come in pretty handy, I'm sure. Yeah, it's pretty simple, you know, just for the CPU anyway. It's obviously going to be harder to, like, you know, compare graphics implementations and stuff, but at that point it's you know, it's more fun to like look at graphics. But CPU stuff is finicky, as you must know, since you had, you know, you implemented a Game Boy emulator, right? Okay, so let's see. I'm gonna run, and what do I want to do? Do I want to just like, I think I'm gonna try and run it with the same stuff I was doing in mine thing. So step this many. Yeah, let's just like see what happens here. Repnop says, still a work in progress, but I'll finish it eventually. Yeah, man, you should totally work on it. Emulators are fun. This is my second one. Like, I wrote a NES emulator. That was my first one, and it was super fun and super hard. I really did not look at any emulator code for that one. I just used the excellent documentation that was available and debugged the crap out of it. Oh, I did do one thing though. I did use one emulator, and I didn't use its code. I didn't look at its code, but it had its own trace output mode, just like I had mine. And I looked at its format, and I was like, okay, I'll modify my trace output to match it so that I could like run it with its own trace, mine with mine, and then do a compare. So you can see like the idea of comparing was something that I took with me from the NES days, but I was even more hardcore back then. So Revnop says, I got to the point where I'm debugging CPU instructions because something funky is going on. So similar to me, right? So yeah, you might consider something along the lines of what I'm doing is, you know, if you can get like a clean implementation of the CPU that you know works, and you can kind of integrate into yours, you know, do what I'm doing and just, you know, I don't know if you have like a trace output. You probably have something, right, that like outputs the CPU instructions that are executing, that your CPU is executing. I mean, even if it's like just straight up the hex, you know, values of the instructions, just to trace that out and run it with yours, run it with the one that you know that works, and then compare the two and just see where they diverge, right? And the moment they diverge, like, you're probably right there on that instruction before there's something going wrong, you know, or there's a good chance. Sometimes it's more tricky, like sometimes it's like, you know, an earlier instruction wrote to memory and it wrote the wrong value, and then later on you read it and it's the wrong value, and then that's why you diverged. But yeah, it's but definitely it helps you to hone in. Repnop says, that's a good idea. I'll probably do that. Yeah, well, let me know how that goes, man. And if you do decide to stream, also let me know. I'll totally like to watch that. Okay, so I hit this I actually don't want this breakpoint. Take this off. Super curious if we're gonna. Okay, so we actually do break at 0020 in that with that CPU. So let's see what happens here. If we step, wow. Amazing. Okay, so that's super interesting. We're getting into the same spot with my CPU implementation and the other one. Just want to be sure that we are indeed running this one. We must, but you know. Yeah, we're totally running. Okay, so the last thing I'm gonna do is, yeah, it's really weird. So let me just try something else. I have the Vectrex emulator here. Let me try and load the same exact ROM in this guy, like the full emulator itself, not the hacked version of the CPU into mine. One thing that sucks about this emulator is that it doesn't support spaces and paths, and like all the ROMs have spaces in it, so I have to like do this kind of stupid copy paste removing spaces stuff, but it's okay. Okay, like that. So this is how we run it with Vectrex. You're actually going to see the output. Yeah, there's the output. So let's see what happens. Does it actually get through this? Okay, so black screen. That's not a great sign. It just might be a ROM issue then. So sorry. Actually, let me mute the sound here. There we go. Yeah. So either like my CPU and that CPU is doing the same bad thing, or there's something wrong with this ROM, which is possible, right? Okay, so you know what I'm going to do is, rather than jump into mine, I'll try ROM in Vectrex, and if Vectrex supports it, then I'll try it in mine. I'll go the other direction, which I think makes more sense. So let's try armor attack. I don't even know which one to grab here. You know what's funny is the fact that some of these are larger than 4096. Repnop agrees. Let me just take the base one here. Remove the space. Oops. Yeah. And Vectrex. Let's go in here. Does armor attack work? Okay, that's better. See a title screen. Okay. This might actually be a ROM that works. There we go. I think I can actually play it. Cool. Collision detection. Oh man, a helicopter. I never played this game. Oh yeah, I can shoot missiles. Oh shit. Oh yeah, good. Oh, I think I got that helicopter. Wow, that's cool. Yeah, Repnop says it's probably a bad dump. I totally agree. I mean, it's like this ROM for animation, you know, with a light pen. So probably no one ever really tried it. Because I mean, what are you gonna do, right? You have to like emulate the light pen with a mouse or something. I guess that's possible. But I don't think it's been done. But I should do it, right? Okay, so this ROM works. Wow, 2 tanks. So cool. So let's stop that. And let's try this ROM now with mine. So let's grab armor attack. Yeah. Sorry. Do this. Okay, and I'll go back to using my CPU. Okay. So obviously I have no graphics, so it's less exciting, but let's do this. A few things I like to do. I'm gonna take off my breakpoints. So by the way, your Game Boy emulator, what are you writing it in? Oh, so you're leaving. So yeah, no problem, man. Thanks for hanging out for a little bit, and hope to see you next time. Which, if all works out, it should be next week on Monday. Oh, Repnop's writing it in Rust. That's so cool, man. I totally want to do that. Were you inspired by Ferris? Writing his N64 emulator first, and now his Virtual Boy in Rust. This is Repnop's GitHub here. I could totally watch it. I'll even star it. Barnacle Boy. Love the name. Yeah, I love Ferris's stream. It's a great stream. And he's a smart guy. So it's always fun to watch people like that write awesome stuff. So this looks really cool, man. So yeah, don't give up. Keep working on it. Did you know C++ or like C or a similar language before that? Because I think it helps, right, to know C++, to learn Rust, from what I've seen. You fiddled with C beforehand, but were you mostly using C#? That's cool. Actually, C# is probably a good language too, to like get into Rust. There's definitely a lot of overlap, but there's also the part of Rust that has to do with a bit lower level concepts, a bit closer to memory and to way C++ works. By the way, I actually like C#, and I have done quite a bit of it. Although I like F# more. I don't know if you've played with F#, but it's really cool. Anyway, don't let me keep you, man. I know if you gotta go, it's 11:30. You probably want to go do your thing, so don't let me keep you. So yeah, here it looks like so far so good. Been running without any problems. I am running in debug, so it's significantly slower. So let me try and release. Repnop says he tried learning C++, but got really confused. Well, I mean, if it's like your first language, yeah, it can be pretty tricky. I think my path was a bit easier. I started learning, I mean, if we don't count like early basic days where I did a bit of basic, yeah, like, oh, sorry, you meant F#. Okay, you tried to learn F# and you got confused. Okay, sorry, I misunderstood. Yeah, no, you know what? Me too, at first. At first I was like, what is this weird language, with missing a lot of parentheses. But actually, I found a couple of good references. So if you're ever really interested in learning it there, I can send you a couple references. There's actually this guy who's a C# expert. Like, this guy really knows his C#, and like not like C# from 10 years ago, but like modern C#, and then learned F# and kind of put together this really great blog with articles of like comparing and contrasting C# to F# but like in a fair way. And then he's like, let's solve this problem, and it's a real problem, and he does it in a C sharp, and it looks perfectly fine. And then he solves it in F sharp, and then he revisits his C sharp application to make it closer to the F sharp one using more functional paradigms. And I found it was really very eye-opening, because if you understand the C sharp and you see the functional style in there, it kind of maps nicely to what the F sharp stuff is doing. So what was that site again? Now I've talked about it so much, I feel like I gotta find it. Damn, what was it called? It's like a really popular F sharp page. I have to like look for it a little bit, but anyway, if I find it, I'll whisper it to you. Was it this one? No, it wasn't that one. It's I have it written down somewhere. It's been like over a year since I've done F sharp, but when I did it, I wrote a game and it was cool. All right, man, I'll let you go. Thanks again for hanging out. I won't talk anymore. All right, so I want to run this in release. Yeah, so far so good. I wonder if we're running the tank game here. Like, I see a lot of F in there, but do I see any calls? Oh, no, okay. I get tricked by the fact that this window's not wide enough. Okay, so man, I kind of wish I could tell it to like break when it tries to execute an instruction in the cartridge space. You know what? I could, right? I totally could. Let me just put a breakpoint in cartridge read. There we go. Or do we? What is this? No, that's totally not right. My output's not right here. But what are we reading here? 1486. So that's cartridge. Yeah, it's because I don't know if that's an instruction that's being read or not. What are we reading here? 1. Why are we reading 1? Disassemble indexed. Try memory bus read. Yeah. kind of annoying that I do this. It's like a fake read from one here. What's this? 0149. Once again, disassemble index instruction. Okay. I can't use this. Well, I'm not crashing. I'm not crashing. So, you know, I'm probably in some infinite loop because I'm not setting certain registers in the VIA correctly. But I'm not crashing. So, you know what? Good enough. Good enough. Just, you know what? I'll be right back. Okay, sorry about that. Okay. Let's try maybe not a light pen game. Bedlam. I think yeah, this one looks like. I'm gonna take the ones that are exactly 4K. I don't. These other things look like. Yeah, I don't quite trust them. So let's just take the standard one. Oh yeah, I'm gonna have to copy this one here. Just make sure this one works. In Vectrex. I'm just gonna do a couple more of these, and it is getting late, so I'm probably gonna stop soon. This is not as exciting as I thought. I haven't really. Actually, did I not fix a bug earlier on? No. Right? Oh no, yeah, I did fix this. That's true. Oh well, it's not really a bug. It was just a printing bug, so it's nothing. Not a real bug, so. Am I wrong? Am I wrong? Yeah, I mean, I have no change in my CPU, so it's just for printing. So yeah, so nothing exciting. So let's just do this one last one. Bedlam, make sure this one works. Okay, so you should see that. Bedlam, it says. It should launch right into the game. Oh yeah, this game is supposed to be really cool. I think I'm like anchored in the center here, right? Am I anchored? Yeah. Oh man, it's tough. Okay, so this game works, and it's really cool. So let me try it in my emulator now. Okay, so far so good. We're running, no crash. Again, no idea if like if we turn on trace, not I think we're like always stuck somewhere in the BIOS, it seems. You know, and there's a really good chance that this has to do with the fact that I mean, I'm not sure, but like since I haven't implemented the VIA, you know, maybe the BIOS is waiting, or maybe the game did eventually start and then it like called into a BIOS function and is waiting for something here, like some VIA register to some timer, let's say, to like raise a bit or something, or maybe it's waiting for an interrupt. You know, I don't know. There's so much that could be going on here. It's hard to know. So I really need to read more, because all I've done so far is read about the CPU, but I need to read more about the whole system. And like the VIA interface is, and the VIA chip, I mean, is like the core of the Vectrex. You know, so I'm going to probably learn a lot there about the timing and interrupts and input and rendering and like the state it should have, and then that will change the behavior. But you know, good news is I'm not getting any crashes so far when I'm running this stuff. So actually, you know what? I did make a change tonight. That wasn't. I just like had a flash. It's in. Come here. It's in main here. Yeah, my unmapped memory device. Like I have this. And I think I have, yeah, like, oh, that I don't need. Let's reset that. That's good. Yeah, this thing here about like using asserts versus printfs. Okay, I'm gonna go back here to the assertion, because really the right thing here is I think I need to have like some kind of macro that says to throw, like, if I am not in my, like, I want a macro that selects between an assertion and an exception. And in fact, I believe I already have something like that. Do I? In my base.h file here, where I keep like common stuff, I have this thing with the fail handler, where if I've determined that I'm in debug, then it'll throw a logic error. Otherwise, it'll printf. I'm not super happy with this, but like, yeah, like I want something like this, you know, throwing exceptions, and maybe not a logic error, but maybe something more specific, where I can like say, have my debugger catch those exceptions, flush the output, and show me where we failed. So at least I know where we are. And then when I'm using Visual Studio, I can get the benefit of the assertion by saying, in Visual Studio, I can tell it, like, as soon as this kind of exception throws, I want you to break immediately so I can see what the call stack is and not like lose my call stack and everything. So that's really what I want to do. Maybe I'll do that soon because I keep running into this. I'm almost wondering if I should just do it now. I have about 15 minutes. How many asserts do I have? That's so weird. Okay. I mean, some of these will remain asserts. That's fine. Oh yeah, I'd written this cool truncate casting thing. Totally forgot about that. Yeah, like stuff like unmapped address and stuff like that. Like, do I really want to assert here? Probably not, right? Although unmapped, I don't think I'm going to hit unmapped address, but yeah. Like these have happened. Today I got this is in range exception, and yeah, I should probably just use fail here. You see again how fail works? Yeah, I think what I don't like about this is that I have fail, but I don't have the same thing as assert. I would need to add my own. That's what I need to do, is I need to add an assert. So maybe I'll do that. Yeah, let me just go back to Git here. I just want to clean up my little mess here. Yeah, don't want these. Cherry pick those later. Main. So I do want this changed. Let me get this guy checked in and like kind of do it correctly. And I want to check this one in as well. There's a couple of things going on in here. So here, let's do a few changes here. So stage that. Debugger. Load symbols. Supports. Lowercase. Directives. So load symbol supports lowercase equate directives. Put that in. This is some formatting stuff here. Just bring up my differ. Yeah, so let's fix that formatting, and this also fixes formatting along with the size change. And that as well. And this I don't want. So this and everything except for my little hack here. Debugger, fix formatting of what? Just fix formatting for that end up has 32-bit values. There we go. Something like that. And now I gotta just clean up this guy in main. So unmapped memory device. Let's make a file for that. So there it is. Let's bring this. And we're going to need to include what? Memory bus, I think. Yeah. I think that's it. No, memory map as well. Because technically I should have a CVP file for this. Alright, let's put a CVP for the memory map. Okay, that's good. Back to main here, I want to include it. Nice. Love Clang formatting. Clang formats sorting my headers for me. And then I think that's it, right? Because I got the unmapped here. Yeah, and like that's the thing, right? Do I want these printfs here? I actually probably want asserts for now, which would become fails afterwards. Yeah, these are totally becoming, like I'm gonna replace this with my own custom assert soon. Okay, let's build. Ah, yes. CMake. Do I still have this here? I do. All right. Okay. Yeah. Okay, you know what I'll do? Just for now, keep this simple. I'll printf again. And then I'll just put an assert false here for now. like I said, I'll replace this soon enough. Okay, so that builds and runs. So, new file, changes to main, looks good. All right, so add unmapped memory device to try to capture when games try to write to unmapped memory, to the unmapped memory address space, which is commit. Okay. So it's getting late, but I'd like to get this thing done. So let me just try and do something now and see if I can do this. So all I really want is some kind of assert macro, very similar to what I have for fail. So this is what I did for fail, because I don't have assert here, no. And I'll do like so assert like this. So we'll assert the condition, and we'll say, what do I say? Do I do the do while zero trick? I know I get some warnings sometimes for this kind of thing, so I might have to do something there. If not condition, fail. Fail, but it would be nice to, yeah, I'll stringize the condition in that case. I'll say like assert failed, and then man, I haven't written macros in a while. How do I stringize again? Yeah, I thought it was pound. Okay, so stringize condition. Can I do that? Oh, that's fancy. Wow. Applying format for the win. So assert does if condition, not condition, then just call fail. Maybe I don't need to do while because I got the fail here. And then I want one like define assert with a message. Condition dot dot dot. Fail, I'll say assert fail. Oh, I think I could just pass it to fail, right? VARgs, can I do that? No, I gotta do a formatted string here. But that's what this guy's doing. Yeah, I can just pass VARgs here. Does that make sense? I think like this. I'm gonna have to try it. Okay, so let me just try these in main. I have a feeling these don't work just yet. Assert false. Assert true as well. Do these compile? Compiles. That's a good sign. Oh yeah, so true got optimized out. Let's build and debug. That's interesting. Great. Unhandled exception. Beautiful. Logic error. And okay, cool. Assert failed false. That's perfect, right? Do I have my try-catch harness in here? Is that why it worked? I do. I have a try here anyway. Oh yeah, and I have one in here. Wonderful. So at least when I execute instructions, I'm catching that. That's cool. Okay, great. So I might, move that up into just the run of the debugger rather than put it in execute instruction. We'll see. Back to main. Although having it here is nice, yeah, because then I can execute the next instruction and all that. So maybe it makes sense here. Yeah. Okay, let me test the ones with messages. Assert message. Make it a bit more interesting. A should be 2. Oh, did not. Yeah, quite good. And then we do the same assert. Okay, not compiling. Oh yeah. So it's not liking this. And the reason for that is I really need to wrap my condition in this. Okay, complaining about, oh yeah, I'm missing my while. Clang format is really cool. Missing semicolon here. Yes, indeed I am. Okay. Yes. Oh man, I gotta get rid of that one because it's gonna. What's funny is that there's a throw here. There's no try here. How did I end up in my debugger? What? Okay, I gotta see that again. Okay. Oh, and I hit F5 and I come here. How's that? I'm a bit surprised because I'm throwing here. I'm throwing with the message a logic error. So if I don't have a catch, why does it end up continuing? Shouldn't it just like exit the program? It's a bit worrisome. So here's another logic error. So we're in the VC runtime. And then I end up here. It must be something to do with the way the debugger is managing this. It doesn't seem to make all that much sense to me. Now we just continue. That's messed up. That's totally messed up. How can I have a throw in a function here? Unless it's because it's being inlined. But then the throw would be right here. So, okay, I guess I gotta try this. I feel like I'm losing my mind here. Like, will this not end the program? What's the problem? Unreachable code. Fair enough. Okay. Here's my throw. I wonder if it's just this. Is it like the debug runtime and the way Visual Studio allows me to like catch when an exception like this happens? Because like, look, it looks like I'm here. And if I, yeah, and it continues running. What? Okay, I'm not like a C++ exceptions expert because I haven't done them a lot, but I guess the question is what happens if you don't have a try catch, right? That's probably what's going on here. It's because I don't have a try catch. That must be it. Throw without try. What? Oh, maybe this one. Okay. I'm just gonna say it's because of no try. If I put a try here and like a catch here, and I put like some more code down here, so now I really should not reach this point here. Oh, all right, I gotta get rid of these guys here. Or you know what, I'll just move this up. But I mean, I think we already have our answer. Anyway, I don't care that much about this. There we go. All right. So it looks like, anyway, it's not complaining in Visual Studio about my do while. I might get error. I might get like warnings in Clang or GCC when I eventually compile with those guys that it won't like this, and I might have to put in some annoying like ignore this warning or whatever. I mean to do this, but Visual Studio doesn't seem to mind. So the trick now is that I've got this, right, and I would like to go in and replace a lot of my asserts with one of these, assert or assert message. I have it done so that if I define, if it sees the debug is defined, it sets this to 1. Otherwise, it's not. I'm not sure I want to do that. I think what I'm going to do instead here is have like another macro, something like define like fail handler throws or something. And for now, I'll just set it to 1. And eventually, like what I'll do is I want to set that to 0 for like when I'm shipping or something like that. And I don't really want exceptions. I don't know, something like that. So if the fail handler throws, we'll do that. Actually, what did I do before? I always threw. Okay, no, so so I actually always threw. It's funny. So this is just a question of whether I print or not. Okay, whatever. So I don't. Okay, you know what? Forget that. I'll just keep like this. For now, I'll just always throw. I'll worry about printing and stuff later. or I'll just print always. I think I know what it is. It's because I want to call fail. I might need to do like two different things, like a fail handler and an assert handler, blah, blah, blah. But for now, I'll route everything through fail. Yeah, I'll just do this or something. It'll say fail, assert failed, whatever. It's okay. Actually, did I see what it looked like when it printed? I wanted to see the printouts for these ones. Fail, assertion failed, A equals 2. Message, A should be 2. Yeah, I like it a bit. One thing I want to change. Maybe I just want it on one line. I'll say assertion failed. I'll say condition. Condition. Put the condition. So instead of a new line, I'll put message or tab. It's getting late. Okay, yeah, this is nice. This is nice and readable. Okay. Yeah, I think I'm going to stop here, and next time, or maybe off stream, I'll go through and replace a bunch of my asserts here. And it's not all of them, but it's a lot of them that I would like to replace with fails. Stuff like this. Yeah, this would totally become a fail. You know, it'll look like, oh no, I mean assert with caps. And it'll be like this. Assert false with a message. Oh, what's this? Too many actual parameters for assert. Oh yeah. There we go. And actually, you know, while I'm testing it, let me see if it makes sense with the printf style. So, where was it? Assert false. In unmapped, yeah, this is the guy that I would have wanted to try. So it'll be like assert message. Yeah, like this. Does this build? It does. I mean, technically, this should be a fail. Because if I do assert false, that's the same thing as just saying fail, right? But when I do want to put an assert, this should be a fail. Which actually brings up the question of, do I want fail and fail message? I have a few fails already with a message, so I might want to fix those up. And maybe I can have like a fail with nothing, which is just like, I have nothing to say. Just go ahead and fail. Maybe that'll be more consistent. I was just thinking, do I even need a cert message? Now that I come to think of it. Do I need to have this? I mean, I could put, it's because I just won't know if it's empty or not. That's the thing. And then I'll just have no message. Maybe that's okay. You know, like maybe I could just do that. Like it'll end up like this, where you could or couldn't, you could put a message, or you could decide not to put a message. If you don't, oh, that didn't fail actually. You get something like this, which kind of looks, you know, kind of weird, but whatever. Who cares, right? Assertion failed. Here's condition. There's no message. But it's simple, nice and simple. I use assert like this, or I use fail. I like it. So yeah, and then like I was saying, you know, well here I just use that, but anywhere where I actually have real asserts. Do I have any real asserts anywhere? I do. Weird stuff. But like stuff like this, again, these are fails. I don't know why I didn't just use fail in the first place in these cases. I'll leave this guy alone. So stuff like this, CPU. Yeah, this is not a failure because this is more of a programming error. I should never actually go here. Yeah, this is like just a specialization that should never occur. Like this is the base case, the base template. We should never actually call this one because they're specialized for the only ones for which it should ever be called, indexed extended direct. If ever my code were to call it for a different addressing mode, that would be an error, and I would want that caught. But it's not something that would come from executing ROMs, so that's not a case where I would want to use my specialized assert, I think. I don't know. So it's like two different asserts, right? I don't know. Maybe I should just use it everywhere. Yeah, that's true. One thing that's nice about the built-in assert is that it shows you the line number and all that. I'm gonna have to beef mine up a little bit if that's the case. Yeah, but it's okay. It's good for now. Okay, so I'm gonna stop here because it's getting late. I can at least, do I want to check this in yet? Maybe not. Maybe I'll wait a little bit. Kind of think over these changes a bit. Maybe I'll go in and add the line number and all that, just the way this way we have the information we want. So yeah, I think that's it. So thanks for watching, guys, and join me. I should be streaming next week on Monday if everything sticks to schedule. So yeah, hope to see you guys next stream. Take care.